Okay. Hello everyone and very good afternoon once again. So welcome back to the second session of the chapter Theoretical Probability Distribution. So good afternoon guys. So first of all, hit the chat box and show who all are live here. So we are going to start our second part of the chapter, which is Poisson distribution. So Poisson distribution is again one of the interesting topic and one of the most important topic from exam point of view. एंड बहुत सारे स्टूडेंट्स ऐसे होते हैं जिन्हें इस चैप्टर से डर लगता है। जी हाँ, इस चैप्टर से डर लगता है। तो अगर आप उनमें से हैं तो आज के दिन में आपको ये डर खत्म करना है, रिमूव हो सकता है ये डर। तो बिल्कुल हम शुरुआत से लेकर के लास्ट तक बने रहेंगे विद पॉइसन डिस्ट्रीब्यूशन। सो इन दिस सेशन वी आर गोइंग टू डिस्कस ऑल द बेसिक्स with all kind of questions which are based on this topic, Poisson distribution. All right. Okay, so let us begin with the topic Poisson distribution. Now, what is basically the Poisson distribution? So it is a part of discrete probability distribution. We have discussed in the previous session, there are two parts, whether it is discrete and second one is continuous. So this one is the part of discrete distribution. All right. I think I'm unable to see the comments of the students. So guys, अगर आप लोगों ने कमेंट नहीं किया है तो एक बार फटाफट से कमेंट कर दे ताकि मुझे पता लग जाए who all are live. All right. So साथ में हम हमारा चैप्टर शुरू कर रहे हैं. Okay. So Poisson distribution, it is a part of discrete probability distribution and it was given by Simon Dennis Poisson. It was given by Simon Dennis Poisson. And he introduced this concept in the year 1837. So it was way back, near about 200 years ago. So now, there are some basic conditions which are applicable for Poisson distribution. So what are those basic conditions which are applicable for Poisson distribution? So we are going to discuss those. So the first condition says the probability of finding success is very small. Time interval is a constant. That means here the probability of success is very, very low. And it is such that it is near to zero. So what is the basic condition? The first condition says the probability of success. Probability of success is very low. It is very low. Such that probability tends to zero. We are not putting equal to sign. We are putting an arrow sign and this arrow means tends. And 10 means it is near to zero and not exactly zero. All right. Then the second thing is number. Number of trials, that is number of experiment. So number of experiment are very large. Number of trials or experiments are large in number. So there are so many experiments and the probability of success is very, very low. Yes, now I can see the comments of each and every person. Mayur is with us. Good afternoon, Mayur. Then Balasan, Vidhi, Jyoti, Bhumika. Welcome guys, welcome everyone. So here we are discussing the conditions for Poisson distribution. The first condition for the Poisson is that probability of success is very, very low, such that P tends to zero. And number of trials are very large, such that N tends to infinity. The value of N tends to infinity. Okay, so one is very small, other thing is very large. If we combine both of them, we get mean, because the formula to calculate mean is n multiplied by p, as we discussed in the previous section. So n is very large, p is very, very low, and if we multiply both of them, what we will get? We will get a moderate result. That means this value will be an average value, not too small and not too large. Then other conditions are similar to what we discussed in binomial distribution. So what are the other conditions? Other conditions is independent. Other condition is independent. Trials must be independent of each other. Then also there are some other conditions, that is the events. There will be two events, and events will be mutually exclusive. So all other conditions are same, but what are the two main conditions which is applicable for Poisson distribution? That is, probability of success is very, very low, such that it tends to 0. P tends to 0. And the second condition is number of trials is large, such that it tends to infinity. All right. So the mean will be a moderate value. Mean is a moderate value. Also, mean will be positive. Mean cannot be negative, because number of trials cannot be negative, as well as probability cannot be negative. So here mean will always be positive. All right. And it can be a finite number. Okay. Now I'm receiving messages of each and every one. Shiva Khan is live, Dinesh, Hira, Manisha, Mansi, Chetan, and Ayushi. Okay. So good afternoon, and live class was not showing in the application. Okay. Do not worry. We are in the beginning phase only. So we have not yet discussed many things. All right. So we have just discussed these conditions, basic condition. So since the probability is very low, so this Poisson distribution is known as distribution of rare events. Poisson distribution is known as distribution of rare events, because the chances of happening these events are very, very low. Okay. Now, these were the basic condition. Now we are going to understand the formulas. So let us write some of the formulas for Poisson distribution. Now the first formula is to calculate the mean. Here mean is denoted by small m, or it can be written as mu, or it can be denoted as lambda. This symbol is known as lambda. L-A-M-B-D-A. Okay. All these are the symbols of mean. And now what is the formula? The formula says n multiplied by p. Just we have to multiply these two things. N into p is mean. Okay. This is the first formula. You can write it down. Then the second one. The second formula is variance. The formula for variance is again n into p. Yes, this is somewhat magical. Mean and variance both are same. In case of Poisson distribution. Okay. Then third one is the standard deviation. Now, what is the formula for standard deviation? It is root of NP. The formula for standard deviation is root of NP. And now the fourth one. The fourth one is to calculate the probability of X. What is the formula? E to the power of minus M. M to the power of X divided by factorial X. So these are the four formulas which we have to remember for Poisson distribution. So mean and variance both are same. So why mean and variance are same? What is the logic behind this? Mean is equal to variance. So since we have understood in this chapter, in this Poisson distribution, that P is close to 0 and sum of P plus Q is always equal to 1, because there are only two outcomes. One is success, other is failure, and their total is always equal to 1. So if P is close to 0, then Q will be close to 1. And any value which is almost 1, if we multiply anything with 1, we get the same result. So if NPQ was the formula in binomial and the value of Q is almost 1, we will get again NP. So mean and variance both are equal, both are same in case of Poisson distribution. So mean is equal to variance. All right. Then the third one was standard deviation. It is root of NP. And the fourth formula is e to the power of minus m to the power of x divided by factorial x. So now what is this m here? M is the mean. M is the mean, average. Then what is x? X is the required number जो हमें find out करना है, which we are supposed to calculate. So x is the required number. Okay. And e is known as the exponential value. What is e? It is the exponential value, and it is having a fixed value, that is 2.7183. Just like pi. Pi is what? 22 by 7. There is a fixed number. Similarly, e is also having a fixed number, and that number is 2.7183. All right. Okay, let's see what are some doubts from the students. Bhumika is asking about, as similar to binomial, in Poisson also events are independent, exhaustive, and mutually exclusive. Yes, it is correct. Events are mutually exclusive. Then the second one. The next one says the mean variance formula is same. Yes, mean and variance both are same in case of Poisson distribution. Then the next one. The next one says, one second, guys. Okay, the next condition. If x follows Poisson distribution with m as the parameter. X is following Poisson distribution with m as the parameter. Y is also following Poisson distribution with again m as the parameter, but both m are different. Then x plus y will also follow Poisson distribution with parameter m1 plus m2. M1 plus m2. This is known as additive property. This is known as additive property of Poisson distribution. And what this property want to say? This property just says that if x is following Poisson distribution, y is following Poisson distribution, then their sum x plus y will also follow Poisson distribution. And the parameters will be m1 plus m2. The parameters will be m1 plus m2. All right. So this will be the parameters. This is known as additive property. Now here we can understand that there is only one parameter. There is only one parameter in case of Poisson distribution. There is only one parameter in case of Poisson distribution, and this parameter is m, that is mean. So now we are comparing these two, binomial and Poisson. Just make a quick comparison. so that it will not be confusing. We are taking binomial on one side and Poisson on other. So till now, what we have done, we are just comparing. The first thing, in binomial distribution, probability is having a normal value, not too less, right? But in case of Poisson distribution, probability is near to 0. Then second one, number of trials are finite, that is countable normal. But in case of Poisson distribution, n tends to infinity. N tends to infinity. Then the third one, the formula for mean in case of binomial distribution was NP, and in case of Poisson also it is n into p. Then fourth one, variance. Variance in case of binomial was NPQ, but in case of Poisson it is just NP. So mean and variance were not same in binomial, but they are same in Poisson distribution. They are same in Poisson distribution. Then binomial was having two parameters. Binomial was having two parameters, whereas Poisson is having only one parameter. It is having only one parameter. Then what are these two parameters? The two parameters were n and p, number of trials and the probability. Whereas in Poisson distribution, the parameter is m, that is mean. It is mean. Okay, so this is a simple comparison between binomial and Poisson. Then one more point we can say, mode. So in case of binomial distribution, it is unimodal or bimodal. That means it can have one mode or even two mode. Same as in case of Poisson distribution, which we are going to discuss now. In case of Poisson distribution also, it is unimodal as well as it can be bimodal, unimodal or bimodal. So these were some of the points which are having some similarity and some differences between binomial and Poisson distribution. All right, so you can note down this table or you can take the screenshot of this so that it will be easy for you guys to recall or to remember. Perfect. So in the beginning part of this session, we are discussing all the theoretical aspects which are connected with Poisson so that we can easily solve the questions at the later part. Okay. Now we are discussing how to calculate mode in case of Poisson distribution. So the next heading is calculation of mode. Calculation of mode. Now here the condition is almost same, just like binomial. What is the first condition? If n into p. In binomial it was n plus 1 into p, but here it is n into p. Or we can say mean, because mean is n into p. So either we can say np or we can say mean. If n into p is a whole number, it is a whole number like k, then there will be two modes. One is k and second will be k minus 1. K and k minus 1. But if mean is not a whole number, if it is not a whole number like k plus f, then there will be single mode, that is k. There will be single mode, that is k. All right. So these are the two conditions. So let's say if the mean is 4. If the mean is 4 in case of Poisson distribution, then what will be mode? Then the mode will be 4 and 4 minus 1, that is 3. 4 minus 1, that is 3. And if mean is 4.6, then what will be mode? So we have to just remove the fraction part, remove 0.6. What is left? We are left with 4. So mode will be equal to 4. Mode will be equal to 4. All right. So if you guys have understood till here, you can comment down. And if any queries are there till here, you can ask. After that, we will move towards some of the practical questions. Okay. So अभी तक किसी को भी कोई डाउट है यहाँ तक कि theoretical part में किसी भी condition में, you can comment down and ask. Otherwise, you can say all is crystal clear. Okay. So that we can move forward. Okay, let me take some of the doubts here. Dinesh is asking, in Poisson distribution, mean, mode, and variance all are same. Not exactly, but yes, you can say, because here, if mean is 4, then mode is 4 and comma 3, but 4 will be there. So mean is equal to mode is equal to variance. So yes, you are correct. Yeah, Shiva is also given the correct answer. Priyanka, Petalwala, Priyanka, Mansi, Bhumika, Hira, Jyoti, Priyanka again, Tarang, and Manisha. Okay. Yes, somebody is asking, Manisha is asking, can binomial be a multi-mode? Yes, whenever it is more than one mode, then it can be said as multi-mode. That is multi-modal. Okay. Yes, crystal clear, got it, understood. Yes, 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 great. Okay, so now let us move towards the next portion. Now, there are some of the examples. So these can be asked in theoretical question. So we have to just remember. So Poisson distribution is applied when the total number of events is pretty large. Total number of events is pretty large, but the probability of occurrence is very small. The probability of occurrence is very small. So there are some examples like number of printing mistakes per page of a large book. So book is very large, that is having thousands and lakhs of words, but number of words which are having misprints is very, very less. So in this case, probability of misprints tends to 0. And number of words, number of pages are very large that it tends to infinity. Similarly, distribution of road accidents, number of road accidents on a busy road per minute, on busy road per minute. That means per minute, sometimes hundreds and thousands of vehicle passes, but on an average, we'll see that very few accidents are happening per minute. So again, probability tends to 0. Then the distribution of number of radioactive elements per minute in the fusion process. Again, this is the same thing. And the number of demand per minute for health center and so on. So wherever the probability is very, very low, then Poisson distribution is applicable. And with that, number of trials or the number of things must be large. Okay. Then Khushi is asking, do we have to remember the value of E? Yes, you have to remember the value of E, that is 2.7183. So after doing 3-4 questions, you'll automatically get remember these values. Okay. Mohammed Ahmed is asking, calculation of mode, please explain again. See, Mohammed, what we were discussing here, in case of mode, there are two conditions. First condition says, if the value of mean, that is NP, is a whole number, just like K. अगर ये whole number है, तो whole number है, that means इसका number क्या होगा? 2, 3, 4, 5, decimal में नहीं होगा. Then the mode will be K as well as k minus 1. अगर नंबर 5 है तो मोड होगा 5, 4. अगर मीन 10 है तो मोड क्या होगा 10 and 9. ऑलराइट, लेकिन अगर ये होल नंबर नहीं है, फ्रैक्शन में है, लेट्स से 9.2 अगर है तो 9.2 है तो 0.2 आपको रिमूव करना है एंड व्हाट इज लेफ्ट, 9 इज लेफ्ट. सो 9 इज द मोड. 9 will become the mode. Alright? Okay. So now let us begin with example number 16.11. Now find the mean and standard deviation. Always read the question carefully and what is given and what the question is asking to calculate. So we have to find out mean and standard deviation of x in Poisson variate. This is very much important. We have to understand Poisson or binomial is there, and there is one condition. So from this condition we have to solve mean and standard deviation. Okay, so let us begin. So p is x equal to 2 equal to again and probability of x equal to 3. Now since it is Poisson and p means probability, so we have to apply the formula for probability. So what is the formula? Probability of x is equal to e to the power of minus m to the power of x divided by factorial x. Okay, now let us substitute the values. E to the power of minus m. So m is not available with us because m is mean and we have to calculate the mean. So mean is not available, so we are keeping minus m as it is. Then m to the power of x. Now in left hand side x is 2, so we are keeping 2 divided by factorial 2. Divided by factorial 2. It is equal to e to the power of minus m, then m to the power of 3 divided by factorial 3. So this is the first step. Always apply the formula first. After application of formula, you will automatically get the second step. Now we can cancel some of the things which are common. E to the power of minus m is on both the sides. We can cancel them. M square will also get cancelled. So we are left with factorial 3 divided by factorial 2 is equal to m. So from here we can say that m is equal to 3. M is equal to 3. What is m? M is the mean. So the value of mean is equal to 3. Okay, so we can check that we are getting the correct answer. The value of mean is equal to 3. And also we have to calculate the standard deviation. Now what is the formula for standard deviation? It is root of NP. And for NP is again mean. Simply what we have to do, we have to find out square root of mean. That is root of 3. So standard deviation is root of 3 and mean is 3. So this is the final answer. So in this manner, we can easily calculate the required values. Okay, understood guys, everyone? Yes, Priyanka also gave an example, number of people dying due to COVID per minute. Yes, you are correct. Then Miss Yashoda says your explanation is really too good, understandable. Thanks, dear. Mohammed Ahmed has understood. Great. So everyone is getting the answer. Shiva has given the complete calculation in the chat box. That's great. Yes, so everyone has understood now. Got it. Good going. So now, when I talk about this chapter for the first time, whenever a student do this chapter for the first time, there is normally a phobia. तो स्टूडेंट को लगता है उसको ये चैप्टर समझ नहीं आएगा, बहुत टफ है, बिकॉज ये फॉर्मूला देख करके स्टूडेंट्स घबरा जाते हैं. बट यहाँ पर अगर आपने थोड़ा सा फोकस किया, बेसिक्स को स्ट्रॉन्ग कर लिया, तो ये चैप्टर आपका फेवरेट चैप्टर बन जाएगा, बिकॉज इट इज वेरी वेरी स्कोरिंग चैप्टर. और ये बिल्कुल भी इंटरेस्ट, ये बिल्कुल भी टफ चैप्टर नहीं है, इजी चैप्टर के अंदर आ जाएगा अगर आपने थोड़ा सा सिस्टम के साथ इसको फॉलो किया। ऑलराइट, चलिए बढ़ते हैं हमारे अगले प्रश्न की तरफ। नेक्स्ट वी आर टेकिंग 13th one, 16.13. The standard deviation of a Poisson variate is 1.732. What is the probability that the variate lies between -2.3 to 3.68? 3.68. So first of all, always write down what is given. So we are given standard deviation 1.732. And what is the formula for standard deviation? Root of m. If we square on both the sides, squaring both the sides, what we are getting? 1.732 square is equal to m. So from here, we find that value of mean is equal to 3. We are getting value of mean as 3. Now, what we are supposed to calculate? We have to calculate we have to calculate the probability where the variation is from -2.3 to 3.68. Now, this is the one of the most important thing which we have to find out, that is the probability. Now, since the requirement is such that the value should lie from -2.3 to 3.68. Now, it is clear that x cannot be negative, because whenever we are talking about number of trials, experiments, it can never be negative, and also it can never be in decimal. It will always be a whole number. Like we took the example of like number of persons dying due to accidents. The number of persons dying can be 1, 2, 3, 0, but they cannot be 0.5. 1.25 cannot be possible, is not possible. 3.75 is not possible. Like 3.75 people are dying due to accident. No. 1.73 people is dying due to accident. No, it is not possible. So x is always a whole number. So what we have to see from this range, we have to find the possible values of x. We have to find out the possible values of x. So x cannot be negative, so it cannot be in negative side. So we are left with from 0 to 3.68. 0 to 3.68. So x can be 0, x can be 1, 2, 3. Now it cannot be 4 because x here is less than 3.68. So below 3.68, we are having the 4 values 0, 1, 2, and 3. So these are the 4 values for x. Okay, so mean is available, x is available. Now we have to find out the probability. Okay, so let us apply. So probability from x equal to 0, 1, 2, and 3. So we have to apply the probability formula 4 times with 4 different values of x. Okay, so the most important thing in this example was to calculate x, and x here is 0, 1, 2, and 3. So applying the formula for 4 times. So e to the power of minus m, m is 3. Then m to the power x, x is 0 upon factorial 0. Plus second one, e to the power of minus 3, 3 to the power of 1 upon factorial 1. Plus e to the power of minus 3, 3 to the power of 2 upon factorial 2. Plus e to the power of minus 3, 3 to the power of 3 upon factorial 3. Okay, now we can take common. What is common? E to the power of minus 3 is common. What is left? 3 to the power of 0 upon factorial 0 is 1. Then 3 to the power of 1 is 3. Then 3 square is 9 upon 2. Then 3 cube is 27. Divided by factorial 3 is 6. Now we can solve these. But what we require value of e to the power of minus 3. So how to calculate this value? So we are calculating here. We know that value of e is 2.7183 and we require value of e to the power of minus 3. So this can be written as 1 upon e cube, 1 upon e cube. That means 1 divided by 2.7183 whole cube. So you can find the value of e to the power of minus 3 in this manner. Okay. So after applying this, you will get your result. So just substitute all the values and finally your answer will be 0.65. Your answer will be 0.65. Okay, so you can try it now. I'm giving you 1 minute. You can do your calculation, and if there is any error, you can let me know. Okay, so यहाँ तक का अगर कोई भी आपको डाउट है तो आप पूछ सकते हैं. So जहां पर x की वैल्यू एक से ज्यादा वैल्यूज आ रही है तो हम उसको कई बार बोलते हैं प्रोबेबिलिटी मास फंक्शन. दैट मींस मास वैल्यूज कैन बी केप्ट. एक से ज्यादा वैल्यूज अगर हम उसके अंदर पुट कर सकते हैं, लाइक हमने पुट किया 0 भी पुट किया, 1 2 3 4 एंड सो ऑन. तो कई सारी वैल्यूज अगर हम पुट कर रहे हैं देन इट कैन बी सेड एज प्रोबेबिलिटी मास फंक्शन. सो दिस क्वेश्चन वाज आस्क्ड बाय मनीषा. ओके मनीषा. So we have done this question, which is 16.13. So always the best way to solve the question is write the given values first, think about the formula which is applicable, and then substitute the values in the formula. You will always get your result. Okay. Now, moving forward, okay, Lakshmi is asking, can you please explain again? Sure. So in this 13th example, what was given is standard deviation. The standard deviation is 1.732. Then the probability we have to calculate, but the values should lie from minus 2.3 to 3.68. The value of x should lie between this. Now we know that x cannot be negative, so we will skip the negative values. Now in case of positive values, we have to only take the whole numbers. So we are taking 0, 1, 2 and 3. So up to 3.68, whatever are the whole numbers we are taking, and then we are applying the formula for probability 4 times. One is with 0, then 1, 2, and then with 3. And after applying, we are getting the result. Okay. So just you have to do the simple calculations and you will get your result. All right. Yes. Now the 14th one. This question is again one of the important question, and this has been asked many times in the examination. So it is just like what we have done above in it may be 11th or 12th we have done. It is similar to that only. So here we have to calculate the standard deviation of x. The standard deviation of x. So let us begin this. Px equal to 2 is equal to 9 times of probability x equal to 4 plus 90 times of probability x equal to 6. This is given. Now, since it is Poisson, we have to apply the formula for Poisson. E to the power of minus m, then m to the power of 2 upon factorial 2 is equal to 9 multiplied by e to the power of minus m, then m to the power of 4 upon factorial 4 plus 90 into, then again we have to apply e to the power of minus m, m to the power of 6 upon factorial 6. So here we have applied. Now we can take some of the things as common. So what is common? E to the power of minus m is common. Then on left hand side it is only the one case, but on right hand side we can take common. E to the power of minus m is common. Then we can take m square as common. 9 is also common. Upon we can say factorial 4 can be taken as common. So what is left? M square is left plus 9 also we have taken. So numerator is 10. Then multiplied by. So since m square was taken as common, so we are left with m to the power of 4 and then divided by. So factorials, out of factorial 6, we have taken factorial 4 as common. So we are left with 6 and 5, that is 30. So in this way we have taken common. Now after taking common, we can do some cancellations. So e to the power of minus m is getting cancelled. M square also gets cancelled. Now we can do basic algebra and get the result. Okay. So now we have to just make the basic calculations to get the result. So just we can do some of the cross multiplications and we will get the result. So also we can solve it in this manner. 1 by 2 is equal to 1 upon. What is factorial 4? Factorial 4 is 24. Then inside we can take the LCM. So 3m square plus m to the power of 4 divided by 3. Okay, so you can solve it further and you will get the result. Okay, so what will be the final result? The final result will be 1. Mean will be 1, and if you calculate the standard deviation, it will be root of 1 again, that is 1. Okay, now I think you can do the calculations. Just apply the formula for quadratic equations, which we had done in mathematics portion. All right. Just as you can see, this will be your equation. M to the power of 4 plus 3m square minus 4 is equal to 0. If we break this, divide this, we are getting m square plus 4, m square minus 1, and m square. Now, since we are getting m square into m square plus 4 into m square minus 1 is equal to 0, so we can equate each of them with 0. So m square equal to 0 we can compare, m square plus 4 equal to 0 we can compare, and m square minus 1 equal to 0 we can compare. So we clearly know that the mean cannot be 0 here. In second case, m square is equal to minus 4, it is also not possible. But in the third case, m square is equal to 1, so value of m will also be 1. So if mean is 1, then what will be the standard deviation? It is root of 1, that is again 1. So we are getting 1 as the mean as well as standard deviation. Okay. So always there will be some hint given in the question whether the question is about binomial or Poisson. So like in this case, it was clearly given x is a Poisson variate. So we have to apply the formula for Poisson. If it was binomial, then we have to apply the formula for binomial distribution. Okay. Now let us make the understanding on this next example, which is example number 15. Between 9 and 11 a.m., the average number of phone calls per minute coming to the switchboard of a company is 4. Now, this first line is very much important. We have to focus on this first line. What it says, between this 9 to 10 a.m., the average number of phone calls, average is mean, and this average is equal to 4. So we can clearly see that value of m is equal to 4. Then find the probability that during this one particular minute there will be no phone calls. So what will be the value of x? Since we are saying no phone call, so x will be equal to 0. X will be 0 since there is no phone call. And in second case, this is for the first case, and in second case, what the question is saying, at most 3 phone calls. At most means what? Maximum. At most 3 phone calls. So at most means maximum 3 phone calls. So what can be the value of x? It will be 0, 1, 2, 3. Because maximum is 3. We cannot exceed 3. But it is equal to 3. So this is the value of x. All right. So we are having both the cases. One is having x equal to 0 and other is having x equal to 0, 1, 2, and 3. All right. So now applying the formula in the first one, we have to find the probability. So let us calculate probability of x equal to 0. So e to the power of minus m, m is 4, then 4 to the power of 0 upon factorial 0. So we are given the value of e to the power of minus 4. So what is the given value? The given value is 0.018316. We have to take this value. Multiply by 4 to the power of 0 is 1 upon factorial 0 is 1. So this is the result. 0.018. This is the result of the first portion. Now what about the second portion? For second portion, the value of x is from 0 to 3. So we have to solve this question for 4 times. That is probability of x equal to 0 to 3. So e to the power of minus m, that is minus 4. This is common in all. This is common in all. So we can take this common directly. So what is left? 4 to the power of 0 upon factorial 0 plus 4 to the power 1 upon factorial 1 plus 4 to the power of 2 upon factorial 2 and plus 4 to the power of 3 upon factorial 3. All these are common. Okay. Now we can do the solution. So 0.018316. Inside bracket, it is 1 plus 4 square is 16 upon 2 plus 64 upon 6. Now we can solve this and get the result. So after solving this, we are getting 0.43 as the final result. 0.43 is the final result of the second portion. All right. So Shiva is asking about at most means 3 or less than 3. Yes, at most means maximum. So we can take less than, but not more than 3. Okay. So this one was illustration number 16.15. So what was the hint in this question? ऐसा क्या हिंट है जिससे हमें पता लग जाए ये क्वेश्चन बाइनोमियल का है या पॉइसन का? सो क्लियरली ई वाज गिवन, ई इज गिवन, जिससे आपको पता लगेगा दिस क्वेश्चन इज अबाउट पॉइसन. सो ऑलवेज क्वेश्चन आपको हिंट देगा. सो एग्जाम में आपको ध्यान रखना है थोड़ा सा स्पीड स्पीड आपकी फास्ट होनी चाहिए, कैलकुलेशन थोड़ा फास्ट होना चाहिए. एक स्टेप आप लिखेंगे पेपर पे, बाकी कैलकुलेशन आप डायरेक्टली कैलकुलेटर पे करें. बट इस एक स्टेप को अगर आप लिखेंगे तो उससे क्या होगा, मिस्टेक नहीं होगी, एरर नहीं होगी, ताकि आप इस चीज को देख करके सारी कैलकुलेशन कर ले ऑन द कैलकुलेटर. ऑलराइट, so it is important to write one step in such cases, and after that you can solve on the calculator. Got it? Great. Okay, Priyanka says understood. Now now the next one, 16.16. If 2% of electric bulbs manufactured by a company are known to be defective. So how many are defective? 2% of the electric bulbs manufactured are defective. Then what is the probability that a sample of 150 electric bulbs taken from the production process of the company would contain exactly one defective bulb? Now you have to plan how to solve this question. Okay, I'm waiting for your thinking process. You can wait, you can think for 30 seconds, and after that I will explain how to start with this question. Okay, till then you can think of how you will start your question in the examination. Come on, that's an easy question. So here you have to see, if 2% of electric bulbs manufactured by a company are known to be defective. So what is this 2%? It is the probability of defectives. Probability of defectives. Then what is the probability that a sample of 150 electric bulb, so 150 is the sample. 150 is the sample of 150 electric bulbs. So we can say that the value of n is 150. The value of probability is 2%. It is 2%. Yes, Dinesh has given the answer. Mansi has also given. First of all, we will calculate mean, because the formula for mean is n into p. We are having 150 as n and 2% as p. So 150 into 2% is 3. So we are getting mean as 3. We are getting mean as 3. Then what is x? Because to find out the probability in case of Poisson distribution, we require only two things. One is m and second one is x. So m is already available. Now we have to find out x. The first part says exactly one defective bulb. Exactly one defective bulb. So value of x will be equal to 1. Value of x will be equal to 1. So just apply the formula. E to the power of minus 3 to the power of 1 upon factorial 1. Upon factorial 1. Okay, now you can solve this. Similarly, If I talk about the second portion, then the second portion is more than two defective bulbs. Yes, this one is important. This one is important. The second portion, it says more than two defective bulbs. So how to calculate more than two defective bulbs? Probability of more than two defective bulbs. So now more than two means starting from 3, 4, 5 and so on. It can extend till infinity. Or here if we are saying there are 150 bulbs, then it can extend till 150. So value of x is more than 2. So 3, 4, 5 and so on up to 150. So this is a very lengthy process. Then what can be done? We can do one thing, 1 minus, because the total of all events is always equal to 1. The total of probability is always equal to 1. So we can remove some of the things. If we can remove that probability of x equal to 0, 1 and 2. If we remove this, then we will get the result. We will get the final result. Okay. So let us understand once again in Hindi also. तो यहां पर आपको गिवन है 150 बल्ब्स, कितने बल्ब्स अवेलेबल है और डिफेक्टिव कितने होने चाहिए? डिफेक्टिव शुड बी मोर देन 2. 2 से ज्यादा डिफेक्टिव होने चाहिए. तो 2 से ज्यादा डिफेक्टिव का मतलब हो गया डिफेक्टिव विल बी 3, 4, 5 से लेकर कहां तक? लास्ट 150 तक. अब एक बात हमें ऑलवेज पता है, प्रोबेबिलिटी फ्रॉम 0, 1 then 2 and so on up to last, that is up to 150 is equal to 1. तो हम अगर 1 में से इन सबको माइनस कर देंगे तो हमारी रिक्वायर्ड प्रोबेबिलिटी आ जाएगी. सो रिक्वायर्ड प्रोबेबिलिटी को कैलकुलेट करने के लिए हमें क्या करना है? 1 में से सब्ट्रैक्ट करना है. किसको? P0, P1 एंड P2 को. इसको सब्ट्रैक्ट कर देना है और उससे हमारा फाइनल रिजल्ट आ जाएगा. सो कम ऑन, लेट अस डू दिस. You have to apply the formula for 3 times. You can see here 3 times आपको formula apply करना है and then you will get the result. So 1 minus e to the power of minus 3 is common. Then 3 to the power of 0 upon factorial 0 plus 3 to the power of 1 upon factorial 1 plus 3 to the power of 2 upon factorial 2. Then what is the value of e? ये आपने पहले भी कैलकुलेट किया है in the above questions. You can take value from that. जो भी आपकी वैल्यू आ रही है e की, you can substitute here. Then 1 plus 3 plus 9 by 2. You can solve this and get the result. Okay, so it is very much important to know the concept first, formula, and then solve. Then after this stage, you can learn how to solve it very quickly, very fast on your calculator. But the first step is to learn the things. So now in this session, we are basically learning each and everything with some of the shortcuts. But in the later stage, we will be discussing about the more shortcuts, more fast, more accuracy, which we will be doing for each and every subject, like how to solve, how to do fast calculation in whether it is mathematics, whether it is accountancy, or whether it is any kind of subject. You can do fast calculations with your calculator. So just we will be discussing about the calculator hacks. Okay, so that you can solve your mathematics, your statistics, your accountancy completely on your calculator tips. Okay, so for now, you have to calculate your answer and how much is your answer coming. Roughly 0.58. Your answer will be roughly 0.58. Yes. So Bhumika has got the answer. Then Priyanka has also got the answer. Yes. Then Muhammad Ahmad is asking, possibility of getting defect is only up to 2%. Then how it extend to 150? See, we are talking about one is probability and second one is the requirement. So the question is asking about defective of more than 2. Question is asking about defective of more than 2. And this 2% is the average chances of getting defective. This is the average chance of getting defective, normal probability. But in actuality, scene can be anything because this 2% is based on the estimation. But we have to calculate the facts with the factual data, that is with the X. So X here is more than 2. So that is why we have taken 3, 4, 5, and so on up to 150. Okay, all right, Mohammed. So now we have done with question number 16.16. Let us take a small break now for 5 minutes, and after that we will be back again with some more questions. All right. So till then you can have some water and snacks and then come back in 5 minutes. So welcome back again, guys. So now we are moving further with some more illustrations, with some more questions. Okay. So, okay, there is one doubt from the student. Who is this? Ayushi. Yes. Ayushi is having some doubt. Let us solve some of the doubts. Yes, she's asking about how to solve this calculation, which we have done in 16.16. Okay. See, let me explain. First of all, we have to calculate the value of e to the power of minus 3. So it can also be written as 1 divided by 2.7183 whole to the power of 3. Okay. So what you can do, you can type 2.7183 on your calculator. You can type 2.7183 on the calculator, press into, equal to, and then equal to. You have to press equal to for the 2 times. So when you're pressing equal to for 2 times, you will get the cube. You will get cube. Okay. This is the first step. In second step, you have to press M plus button. Whatever result you are getting on the screen, press M plus button. Okay. Then in the third step, you have to do 1 divided by MRC and press equal to, and then press equal to. You will get your value. Okay. So what you have done, 2.7183 into equal to, then M plus 1 divide MRC equal to. So you are getting the value as 0.04978. This is the value of E. Okay. So this is your value. Now what is left? 0.04978. Okay. Now we have to solve the bracket. So what we are having in our bracket, 1 plus 3 is 4. 4 plus 9 by 2 becomes 8.5, or we can say 17 by 2. So we have to multiply. So this number is on our screen, 0.04978 multiply with 8.5. Multiply with 8.5 and then subtract this number from 1. Subtract this number from 1. You are getting 0.5768. If you are rounding it off, you will get 0.58. Okay. So in this manner, you can solve this on your calculator. Okay, Manisha is asking about we have to solve all additional bank questions for examination. Yes, Manisha, you have to practice all these questions which are given in our study material. So because all these questions are not much lengthy, but you have to solve with your sessions only. Like if we are doing Poisson today, you have to completely solve all the questions related to Poissons in your study material. Then in the next session, we will be doing normal distribution and we will be concluding the chapter. Then in that part, you have to complete all the complete questions from all the sets. Okay. And after that also, if you are having any doubt, we are here to help you out. Okay. So no need to worry. Now the next one, 16.17. Now read this question carefully and you have to think of how you will solve in examination if this question is coming to you. Just find the given values first. Okay. The manufacturer of a certain electronic component is certain that 2% of the product is defective. So there is one figure which is 2%, and this 2% is nothing but probability. He sells the component in boxes of 120. So in one box, how many components are there? 120, and guarantees that not more than 2% in any box will be defective. Not more than 2% will be defective. He is giving the guarantee. Now find out the probability that a box selected at random would fail to meet the guarantee. So what is the probability that the box will fail to meet the guarantee? So first of all, we have to write all the given things. Okay. So what are the given things? So 2% is the probability. Then number of boxes, that is n. N is 120. Now we have to calculate the mean. What is mean? N multiplied by P. So 120 multiplied with 2% is 2.40. 2.40. This is the mean. Now, what is our requirement? Our requirement is to fail to meet the guarantee. Now, when it will fail, if the defectives are more than 2%. If defective is more than 2%, or we can say more than 2.4 defective in terms of values. If we say in terms of value, that is more than 2.4 defective are there, then it will fail. So we have to calculate that the value of X is more than 2.40. So in order to calculate this, what can be done? We can do it other way around. 1 minus probability of value of X less than 2.40. Just as we did above, 1 minus all those things. So what we can do, we can subtract all the possibilities subtract all the possibility from 0 to 2.4 from 1, and we will get the required result. Okay, so what we require? Defective probability with more than 2.4 defects. So now we have to just apply the formula here. Now we know that the value of X can never be in decimal, it will be in a whole number. So up to 2.4, how many whole numbers can be there? It can be 0, 1, and 2. 0, 1, and 2. So these are the three values. Now we can apply the formula for probability. E to the power of minus 2.4. This can be taken as common. Then e to the power of minus m to the power of x. So 2.4 to the power of 0 upon factorial 0 plus 2.4 to the power of 1 upon factorial 1 plus 2.4 to the power of 2 upon factorial 2. So now we can apply this and get the result. So value of E is already given in the question. What is the value? 0.0907. 0.0907. Now we can solve 1 plus 2.4 plus square of 2.4 and then divided by 2. We are getting 2.88. So after doing this, we will get the result. So what is the result? 0.43. And we have to subtract this from 1. So we can write here, subtracting it from 1. So after getting subtracted, we are getting 0.43 as the result. Okay. So this was the 17th one. Now 18th one. 18 is also a good question. And what is given? Let us see. A discrete random variable x follows the Poisson distribution. Then find the value of probability where x is at least 1. Where x is at least 1. This is the first part, and second one is different. So first of all, we will solve the first portion. So what is given? Ex is given, and e to the power of this mean is also given. So we are given the two things. One is Ex. Ex is nothing but the mean. So mean is given. And second one is exponential value is also given. So just apply the formula, probability of at least 1. Probability of at least 1 is equal to 1 minus probability of none. So whenever this is the case, what we have to do, 1 minus probability of none. So now 1 minus, what is the probability of none? None means x is equal to 0. None means what? X is equal to 0. So 1 minus. Now how to solve probability of x equal to 0? So e to the power of minus 2.2 into 2.2 to the power of 0 upon factorial 0. 2.2 to the power of 0 upon factorial 0. Now, what is the next thing which we have to do? Apply the value, substitute the values and get the result. So this is the given value and we can subtract from 1. We are getting 0.89. This is the answer for the first portion. Okay, this is the answer for the first portion. All right. Now, if it is clear till here, you can comment down. Got it? Understood? Clear? Okay. After that, we will start the second point. Now, till here, let's see. Any doubts? Okay. Priyanka Dikshit. Priyanka Dikshit is asking, the trick on the calculator is not working. Okay. See, always you have to be aware about the calculator. If you are having M sign on your calculator, अगर आपकी calculator की screen पे पहले से ही M का symbol बना है, that means memory में पहले से कुछ पड़ा है. तो पहले आपको क्या करना है, इस मेमोरी को इरेज करना है. You have to erase this first. और ये इरेज करने के बाद में आपको ट्रिक अप्लाई करनी है. ओके, तब जाकर के आपका आंसर आएगा. अगर मेमोरी में पहले से कुछ पड़ा होगा तो फिर आपका आंसर करेक्ट नहीं आएगा. ऑलराइट, सो हाउ यू कैन इरेज? यू कैन प्रेस MRC बटन ट्वाइस. इसको 2 टाइम्स प्रेस कर दो तो मेमोरी में जो भी पड़ा है वो पुराना इरेज हो जाएगा. आफ्टर दैट यू कैन अप्लाई द ट्रिक एंड यू विल गेट योर रिजल्ट. ओके, तो जब भी आप नया क्वेश्चन स्टार्ट करते हैं, मेमोरी चेक कर ले, मेमोरी इरेज होनी चाहिए. Okay, so whether it is maths, stats, accounting or any practical subject, just apply this concept and you will get your result very, very fast. Okay, so now what are the comments Priyanka has done? Clear? Yes sir, clear, got it, understood. Bhumika, Jyoti, Ayushi, then Priyanka, Jha, Mansik Mari. Okay, everyone has done. Perfect. Great. Now the second one. Now second one is a bit different, but we have to understand this. Here it is conditional probability. Conditional probability is used. What is given in the second portion? Find out the probability where x is less than equal to 2 divided by x is more than equal to 1. Okay, so this is the format of conditional probability. X is less than equal to 2 divided by x is more than equal to 1. Okay, this is the case. So now let me help you with the recall. You might have done the conditional probability P of A by B. What is the formula? Probability of A intersection B divided by PB. Probability of A intersection B divided by P of B. So this is the formula. So what we have to do, we have to find out the intersection. We have to find out the common between A and B. So numerator में क्या आएगा? The common portion of A and B. Common portion of A and B. And denominator में it will be P of B. That is denominator का probability आएगा upon में. All right. So now what we are doing, let's see. Numerator is A and denominator we are taking as B. So what is A? X is less than equal to 2. So since it is less than equal to 2, so what can be the possible values of x? It can be 0, 1 or 2, but not more than 2. Not more than 2. Then what about b? That is denominator. It says x is more than equal to 1. More than equal to 1 means x will be 0, 1, 2, 3. 0 will not be there. It is, since it is more than 1, so it will be 1, 2, 3, and so on till infinite. So this is x more than equal to 1. Now what is the common thing between a and b? So 1 is common and 2 is common. So in numerator, we have to find out the probability with x equal to 1 and 2. X equal to 1 and 2. And in denominator, we have to find out the probability of x more than equal to 1. Now, since it is more than equal to 1, so the values are 1, 2, 3, 4, and so on. So how to calculate such kind of figure? There is one shortcut which we have already discussed, that is 1 minus probability of none. That is 1 minus x equal to 0. We can apply this. So 1 minus probability of x equal to 0. This will be applied in denominator. This will be applied in denominator. And now we can solve this. Yes, Pushpa is asking about, I am from Hindi medium, so I will get questions in Hindi. Yes, you will get your questions in Hindi only in the examination. Don't worry. So now we have to calculate this portion. So let us solve the numerator one. So for the numerator, p x equal to 1 and 2. So e to the power of minus m. What is the mean? 2.2. Then 2.2 to the power of 0 upon factorial 0. Then 2.2 to the power of 1 upon factorial 1. This is the numerator. Divided by 1 minus p of x equal to 0. So e to the power of minus 2.2. Then 2.2 to the power of 0 upon factorial 0. And yes, in numerator we have taken 0 and 1, but it was 1 and 2. So let's change the value. It is not 0 and 1. It is 1 and 2. 1 and 2. So we are changing the value 1 and 2. Okay. Now you can solve it and get the result. So what is the value of E? It is 0.1108. So 0.1108 multiply with 2.2 plus square of 2.2 divided by 2, it is 2.42. Then whole upon 1 minus 0.1108 multiply with 1. So you can solve this, and after solving we are getting the result as 0.58. 0.58. All right. So this is the answer. So this question was basically based on conditional probability. So there were some conditions and we have to apply here. Yes, Manisha, you are correct. Priyanka has given the answer. Mansi has also given the answer. Good going. So great, everyone. So now we are doing some questions from the back exercise. In the next session, we will be doing normal distribution. Okay. Now, yes. Some of the theoretical questions I'm taking first. 21st. Which one is uniparametric distribution? Uniparametric means what? Having one parameter. So which of them is having one parameter? That is Poisson. There is only one parameter in Poisson distribution, and that too is mean. 22nd. For Poisson distribution, mean and standard deviation are equal? No. Second option, mean and variance are equal? Yes. 23rd, Poisson distribution may be unimodal, bimodal. So it can be both, that is unimodal or bimodal, or we can say it can be multimodal. Then Poisson distribution is symmetric or positively skewed, negatively skewed, or symmetric only when m is equal to 2. Then the next point is binomial distribution with parameters n and p. So there are two parameters, one is n and second one is p, and it can be approximated by binomial distribution with the parameter of m equal to np. So we know that n tends to infinity, p tends to 0, but when we are talking about mean will be a moderate value. It will be an average value. So which of the following will be correct? So option number 1 is having only one condition, B is also giving one condition, C is giving two conditions, and D is giving both the condition. N tends to infinity, P tends to 0, and NP remains finite. NP remains finite. So all the conditions are given in option number D. So option number D will be correct. Option number D will be correct. Okay, now we are moving towards some of the practical questions from set B. From set B, and this is question number 9. We are taking question number 9. If the standard deviation of Poisson variate x is equal to 2. So what is given? The standard deviation is given of Poisson variate. So clearly the question is talking about Poisson distribution where x is 2. X is 2 and p, x lies from 1.5 to 2.9. So now clearly the question was saying that standard deviation of Poisson is 2. So we can write neta is equal to 2. And what about x? The value of x is lying from 1.5 to 2.9. So between this, we are having only one whole number. Between 1.5 and 2.9, we are having only one whole number. So value of x will be 2. Okay, there is only one whole number, which is 2. All right. So now, since we are having the values, now we can find the probability. So for probability, we require mean. So mean is the square of standard deviation, because we are saying that mean is equal to variance, or we can say mean is equal to the square of standard deviation. So here the mean will be 4. So mean is 4. Mean is equal to 4 and x is equal to 2. So just apply this. So probability of x equal to 2. E to the power of minus 4. 4 to the power of 2 upon factorial 2. Okay, now we can solve this. 4 square is 16. 16 upon 2 is 8. So 8 into e to the power of minus 4. Now we can calculate the value of e to the power minus 4 on the calculator. So you can calculate it. Come on. 2.7183 into equal to for 3 times. Then m plus 1 divide mrc equal to. So we are getting the value as 0.018315 and we can multiply this with 8. So the result is 0.1465. Okay. So correct answer will be 0.146. You can change the option number D. It will be 0.147. The correct option will be 0.147. Okay. All right. So this was question number 9. Then the next one. Question number 10. We have already done this kind of question. This one is easy. You can do this. Now 11th one. We are doing the 11th question. It says if x follows Poisson distribution with parameter m and its coefficient of variation is 50. Its coefficient of variation is 50. Then what is the probability that x would assume only non-zero value? Non-zero value. So what will be x? Since we are saying non-zero value, non-zero means it can be 1, 2, 3, 4, and so on up to infinity. It will be the value x equal to 1, 2, 3, 4, and so on up to infinite. It is non-zero value. And coefficient of variation is 50. So we have to find out the probability. So see, we are not having m. So first of all, we will calculate the value of m. So in order to calculate m, we are given CV, coefficient of variation. So what is the formula for coefficient of variation? It is standard deviation upon mean multiplied by 100. ST upon mean into 100. So CV is 50. Standard deviation is not available. Then mean. For mean, we can say that mean is equal to the square of standard deviation, or we can say mean is equal to variance multiplied by 100. Now we can do some cancellations and we will get the result. So what is the standard deviation? The standard deviation is equal to 2. So we are getting the standard deviation as 2. Now, if the standard deviation is 2, what will be the mean? So mean will be the square of standard deviation. The square, that is 4. So mean is equal to 4. Mean is equal to 4. All right. So standard deviation is there, mean is there. Now what we have to do? Now the next part is we have to calculate the probability. We have to calculate the probability. So what is the probability? Probability of x more than equal to 1. So 1 minus probability of none. What we have to do? The shortcut 1 minus probability of none. So 1 minus e to the power of minus 4, 4 to the power of 0 divided by factorial 0. Divided by factorial 0. So let us solve this. 1 minus the value of e is already available with us. The value of e is available. We have just find out in the previous question. So 0.018315. And we can subtract this from 1. We can subtract this from 1, and after subtracting, we will get the result. So how much we are getting? 0.982. We are getting the result as 0.982. All right. Perfect. So till here, if you are having any doubt, you can ask. So let us check how many doubts are there. Okay, Priyanka is asking about non-zero means. Non-zero means which is not zero, but it can be more than zero. Okay, non-zero means which is not zero, but it can be more than zero, because we know that the value of x here is always, it can be always positive or zero, but cannot be negative. So it can be 0, 1, 2, 3, and so on. But the question is saying that it cannot be 0. It is non-zero value. So non-zero means it can be 1, 2, 3, 4, and so on. All right. Okay, any more doubts? Bhumika says no doubt. Dinesh, no doubts. Priyanka says all clear. Okay, so some of the students are having the doubt in coefficient of variation calculation. So let me explain once again. See, what is CV? The coefficient of variation is equal to standard deviation upon mean into 100. Standard deviation upon mean into 100. This is the formula. We are having CV as 50. We are having standard deviation, and mean can be written as the square of standard deviation. So by cancellation, by doing some cancellation, we are getting the standard deviation as 2. We are getting the standard deviation as 2. And since the mean is the square of standard deviation, so we are getting the mean as 4. Mean is equal to 4. Now what was required? Probability of non-zero value. Non-zero value. And non-zero means 1, 2, 3, and so on. And for this, we are having the shortcut formula 1 minus probability of x equal to 0. 1 minus probability of x equal to 0. And after applying this, we are getting the final result. All right. Okay, Samir is asking about, in this question, we have taken the value of 0.018315, and can we take value up to 2 decimal values? See, whenever such kind of values is there, or we can say value is bit small, 0.01, to taking 0.01 will affect our result. So we can take at least 4 decimal places. Okay, so you can take 0.018 and then 3. At least take 4 possible 4 places after decimal. So it will give you exact result. Okay, so now we have done many variety of questions till now. Let us see few more questions. The 12th one. The 12th one, you can try this, because similar kind of question we have taken from the illustration. Because 1.5% of item produced are defective, this is the probability. 200 is the n, and by multiplying we can get the m. So I'm just writing the values. What will be the mean? Mean will be 200 multiplied by 1.5%, that is 3. And what will be x? X will be no defective item. No defective item is x equal to 0. No defective means x equal to 0. All right. Then 13th one, this kind of question we have done. Just apply the formula for Poisson and you can get the result of mean. Then 14th is also similar kind of question we have done. Fifteenth one. Let us do 15th one. 15 says, if for a Poisson variable x, f2 is equal to 3 times of f4. f2 is equal to 3 times of f4. Okay. So now what we have to do, we have to find out the variance of x. We have to find out the variance of x. This we have to calculate. So the function f2 is equal to 3 times of f4. So just what we have to apply, just substitute the value e to the power of minus m to the power of 2 upon factorial 2 is equal to 3 times of e to the power of minus m to the power of 4 divided by factorial 4. Divided by factorial 4. Okay. Now what can be done? We can do some cancellations. These got cancelled. M square will also get cancelled. So what we are left with, factorial 4 divided by factorial 2 divided by 3 is equal to m square. Is equal to m square. And using this we can solve. So factorial 4 means 4 into 3 into 2 divided by 2 into 3. So 3 and 2 got cancelled. So we are left with m square equal to 4. So m will be 2. M will be 2. So if mean is 2, then what will be the value of variance? Of course, variance will also be 2 because mean and variance both are equal. Mean and variance both are equal. So the value will be 2. So correct answer is option number A. So who else has given the answer? Okay, Priyanka and Dinesh has given the answer and the correct answer is 2. Option number A. All right. So now these were some of the questions from set C. Now from set B. Now we are moving towards the next set of questions, that is set number C. Set number C. So the 9th question, this question we have already done from the illustration. Then the 10th one. So the 10th one is having those points which we have already covered. So what are the points? A random variable x follows Poisson distribution and is having the coefficient of variation as 50. So CV is equal to 50. Then we have to find out the value. किसकी value find out करनी है? Probability where x is greater than 1 divided by x greater than 0. So this pattern also we have discussed. So from CV we can calculate mean. From CV we can calculate the mean. And from this is the most important part, that is the conditional probability. So if the numerator is, let's say, a, x greater than 1, and the denominator is x greater than 0. So greater than 1 means 2, 3, 4, and so on. And B says greater than 0. Greater than 0 means 1, 2, 3, 4, and so on. So what is the common portion between them? Because in numerator, we have to write the common portion, A intersection B, and then divided by probability of B. A intersection B divided by probability of B. So what is the common portion? 2, 3, 4. Here also 2, 3, 4, and so on. And so on. It is common. So in numerator we can write this as probability of x equal to 2, 3, 4 and dash 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 upon what is required, probability of x equal to 1, 2, 3 and so on up to infinity. Okay, so in this manner we can solve. And also now we have done multiple questions, so you know that how to solve these numerator and denominator. So since the value of x is starting from 2 till infinite, we will subtract from 1. 1 minus p x equal to 0 and 1 in the numerator, and 1 minus p x equal to 0 in the denominator. So you can solve this and we will get the result. Okay, so this question was from set number C. So now overall, if we see, we have covered all the variety from this Poisson distribution. So what is your homework today? You have to try each and every question, whether it is from set A, B or C or the additional question bank. All right. So now in the last 10 minutes, we are going to recall and revise whatever we have studied in the today's session. Okay. So let us recall. So in the beginning of the chapter, we have classified Poisson distribution into two parts. One was discrete and second one is continuous. In discrete, there are two distributions. One is binomial and second one is Poisson. And in continuous, we will be doing normal distribution. So binomial was covered in the first session, and in today's session, we have covered Poisson distribution. So Poisson distribution was given by Simon Dennis Poisson in the year 1837. So there are few basic conditions for the Poisson distribution. One is that probability of success is very low, very small, such that it tends to 0. So it is very, very low. Then the probability, then the number of trials are large, such that n tends to infinity. N is tending to infinity. Then all other conditions are similar to binomial. That is, the events are independent of each other. Events are mutually exclusive, and also they are exhaustive. One is success, other one is failure, and total of them is always equal to 1. Okay, so all other conditions were same. Then we had learned about the 4 formulas. One is mean. The formula for mean is n into p. Then variance. The formula for variance is again n into p. Then standard deviation is root of np, and the fourth one is the probability. The formula for probability is e to the power of minus m, m to the power of x divided by factorial x. Okay, so these were the 4 formulas which we had learned for Poisson distribution. Then Poisson distribution is known as uniparametric because it is having the single parameter, which is m. Then mean is denoted by m or even mu. Variance also we had done, it is denoted by neta square, or we can say m. Then binomial distribution can be unimodal or bimodal, and it is depending on the parameter, which is m. So it can be unimodal or bimodal. Then Poisson approximation to binomial. What this point says, if n, that is the number of independent trials of binomial, the number of trials in case of binomial becomes large, such that n tends to infinity. इसका मतलब क्या हुआ, अगर बाइनोमियल डिस्ट्रीब्यूशन में हम कहते हैं n की वैल्यू इंक्रीज हो रही, इतना इंक्रीज हो जाए कि n टेंड्स टू इंफिनिटी, एंड साथ में p की वैल्यू कम होने लग जाए, इस तरह से कम हो रही है कि p टेंड्स टू 0। तो जब ये दोनों चीजें होने लगती है बाइनोमियल के साथ, तो बाइनोमियल कन्वर्ट हो जाता है किसमें? पॉइसन डिस्ट्रीब्यूशन में। तो इट कन्वर्ट्स इनटू पॉइसन डिस्ट्रीब्यूशन। और जब हम n और p दोनों को मल्टीप्लाई करते हैं तो जो वैल्यू आती है दैट इज अ मॉडरेट वैल्यू एंड इट इज अ फाइनाइट वैल्यू। इट इज अ फाइनाइट वैल्यू। Then additive property of Poisson distribution, क्या होती है additive property हमारी? अगर x फॉलो करता है Poisson distribution को with parameter m1, y फॉलो करता है Poisson distribution को with parameter m2, then x plus y will also follow the Poisson distribution with parameter m1 plus m2, m1 plus m2. Okay. Then we discuss the applications, कहां पर अप्लाई होता है? बहुत सारी जगहों पे एप्लीकेबल होता है, where the probability is less, is very less, or we can say near to zero, like number of road accidents per minute or number of COVID patients which are dying per minute, or we can say number of misprints in a thick book is also the example of Poisson distribution. So all these are the examples of Poisson distribution. Then we had discussed about the differentiation or some similarities between the binomial and Poisson. In binomial, p is having a normal value, whereas in Poisson it tends to 0. In binomial, n is finite, whereas in Poisson n tends to infinity. In binomial, mean was np. In Poisson also mean is np. Mean is np. But for variance, in binomial, variance was npq, but here the variance is np. Binomial was having two parameters, but Poisson is having only one parameter. Two parameters were n and p in binomial, and single parameter is mean in Poisson distribution. Then calculation of mode in binomial distribution, it can be unimodal or bimodal. Same as with Poisson, it also can be unimodal or bimodal. Then we had talked about the calculation of mode in case of Poisson distribution. If the value of mean is a whole number like k, then the mode will be k and k minus 1. And if it is not a whole number, then the value of mean will be a single value, that is k. That is k. Okay. So I am doing the recap in both the languages, Hindi as well as English, so that there is no challenge to everyone. All right. So we have done all these questions and applied all the formulas. Then also we had discussed how to calculate the value of E using the calculator. The value of E is 2.7183. So using that, we can find out any value of E, whether it is e to the power of -1, -2, and so on. We can calculate that. But if the power of E is in decimal, then the question will always give you the value, because it cannot be calculated directly on the calculator. Okay. Just like there was one value in the question, like if E is having the power of, let's say, -2.2, then in that case what will happen? In that case the question will give the value, because we cannot calculate the decimal portion. So in that point the question will give you the value of E. Otherwise we can calculate accordingly. Okay, then here was the summary of binomial and then Poisson. So I think all points we have covered from this summary also in the recap. Yes, we have covered them. And the next point will be of normal distribution. In the next session, we are going to start with the normal distribution, and there are different ways to solve the question of normal distribution. So that will be a bit of lengthy topic. You have to be prepared with all your pencils and pen copy, because we will be making some of the diagrams to solve the questions, and that method will be very, very easy to solve normal distribution. Okay. Okay, let's see who all are commenting. Priyanka is asking, sir, had you completed your foundation in first attempt? Yes, there. Then Lakshmi says, Mansi, okay, Mansi says, I had understood all the concepts very well, and thanks for this class. You're most welcome, Mansi. So to each and every one, so if you have enjoyed the today's class, you can comment down below. Okay, so your comment reaches to us and motivates a lot to take a lot of classes for you guys. Okay. So the main thing is always focus on the basics. If your basics are strong, you can solve any kind of question, any variety of question. No one can stop you from solving the questions, from getting the answers. Okay, so always strong your basics, strong your calculations, and always you will get very, very, very good marks. Okay, and always respect your elders, respect your teachers. They also give you a lot of blessings, and with those blessings we also reach to great heights. So these things are also important in life, right? Okay. Then Priyanka says, thank you, sir, it was nice experience with you. That's great. Samir is asking, what is the weightage of chapter in the examination? See, normally there is no such fixed weightage, but if we talk about the average, so from this particular chapter, theoretical distribution, on an average, 4 to 5 questions come. On an average, 4 to 5 questions come. So this is important chapter, and it is not much difficult. This is easy chapter, just based on simple concepts and small formulas. Just apply those and you will get all your results. Okay. Ashna says, when you explain this chapter, we found very easy. That's great. Lakshmi says, you are an excellent teacher. Your concepts are reaching us with clarity. That's amazing. Mayur says, all crystal clear. Ayush is asking, sir, had you done all your chapters of all subjects at foundation level? Yes, I did. Great, great. So thank you guys, thank you everyone. It was nice being with you, and you all were so much responsive, and you were very interactive in today's session, and most of you have given the correct answers. So I hope in the next session also you will be giving a lot of answers, and be prepared with more what we say, the formulas and all the learnings which we have done in this chapter. Okay, so we will be summarizing this chapter in the next session, that will be on Monday, that is 7th of March. So till then, bye everyone, take care, see you soon.